This is your problem set for Module 3, Lesson 3. Lesson summary says there's two types of sequences that we've studied. Arithmetic sequence. It's a sequence that's called arithmetic if there is a real number, d, such that each term in the sequence is the sum of the previous term and d. It's the difference between the two terms. Okay? Now, the geometric sequence is called a geometric if there is a real number, r, such that each term in the sequence is a product of the previous term and r. That r is the ratio factor. Whether we're multiplying by 6/5, right, or we're dividing by 8 each time. Okay, your ratio, that's your ratio. So, let's look at this for problems 1 through 4. It says find the first 5 terms of each sequence and identify them as arithmetic or geometric. These should be easy. We should be able to rattle these off real quick. All right? First of all, this is, I'm just going to write an A or a G for arithmetic or geometric. Okay? So this is A. Now, anytime you're finding, okay, if you say it's A, or if it's geometric, you need to tell me what the pattern is. So, what is the pattern for this arithmetic sequence? Okay, so it's adding 4 to the previous term, right? So that's what I would write. I would say plus 4 to previous term. I know what I'm doing. I'm going to add 4. A of n is my previous term. I'm going to add 4 to it. Okay? Now, A1, which means your first term is -2. Well, I'm going to use that to get n plus 1. Okay? Because n is essentially A1. That is -2. Well, n plus 1 is going to be my second term. And I'm going to use my previous term for that. So what is -2 plus 4? What is 2 plus 4? What is 6 plus 4? And what is 10 plus 4? There we go. Does anybody not understand? Everybody got that? All right? Do number 2. That is a geometric sequence. What is the pattern? Your what? Okay. You can say that you're multiplying by 1/4 or what? Yes, you're either multiplying by 1/4 or dividing by 4. So I'm going to put divide by 4. From the previous term. Okay? Now, it already tells us that our first term is 8. If our first term is 8 and we divide it by 4, we get 2. What's 2 divided by 4? 2 divided by 4 is 1/2, right? It's 1/2. Now, what is 2/4 or 1/2 divided by 4? 1/8. That might have confused you there, Michael. Let's write this as 1/2. If we divide by 4, that's going to be 1/8. If we divide by 4 again, that's going to be 1/32, 1/32. Okay? So it might be easier sometimes to divide by 4, then multiply by 1/4. Right? It's easier to say 8 divided by 4 is 2. 2 divided by 4 is 1/2. Well, 1/2 times 1/4 would be 1/8. 1/8 times 1/4 would be 1/32. Okay? So sometimes it'd be easier. Know your tricks. Okay? Number 3. That's going to be a what sequence? It's going to be arithmetic because we are subtracting 19 from each. So negative 19. Okay? I'm not going to put from the previous term. You should know that we're going to do this to the previous term. Okay? Now, we start with -6 here. So that is our first term. And we just plug it in. What's -16? Ooh, this one might be a little tricky. Did I write 16? Oh, sorry, not -16. That's -6. What's a -6 minus 19? -25. What's a -25 minus 19? -44. What's a -44 minus 19? -63. Good job. What's a -63 minus 19? -82. -63 minus 19. All right, there's your first 5 terms. Now, 4 says that we're going to do 2/3 A of n. Okay? What is that? That is going to be a geometric sequence because we are multiplying by 2/3. So this is geometric, and we're going to do times 2/3. So if we start off with the first term as 6, what is going to be our second term? Well, what's 6 times 2? What is 6 times 2? Divided by 3. 4? Guys, 12? That's all you have to do. That's exactly what 6 times 2 divided by 3. That's all you have to do. You're multiplying by the top and then dividing by the denominator. That's all you're doing. So what's 4 times 2? Divided by 3. Let's leave it as an improper fraction and call it 8/3. What's 8/3 times 2/3? 16/9. What's 16/9 times 2/3? 32/27. That's it. I hope that's it. Yep, that's all of them. Just all you do. You're always using the previous term to come up with the next term. It's that easy, yes. All right, page 2. For problems 5 through 8, now we're looking at the sequence, and we're coming up with whether it is arithmetic or geometric, and we're writing the recursive formula. Okay? Writing the recursive. Now, there's a couple of different ways that we have talked about the recursive, right? We have said we've used the function notation, or we said f of n, and we've used a of n, right? Does it matter? No. It's just how you're talking about it, okay? Now, for problems 5 through 8, oh yeah, here we go. Arithmetic or geometric. So for 5, what is it? It's arithmetic, and what are we doing? Well, let's see here. It's arithmetic, and we are adding 7. Now, how are we going to write that for a formula? Let's call it f of n. F of n plus 1 is going to equal what? F of n plus 7. That's it. It doesn't matter. It literally doesn't matter. It's the same thing, Jordan. Okay? Now, number 6. 440, 400, 4,000. What's happening here? Or times 10, and that would be a geometric sequence. Let's just call it times 10. So f of n plus 1 is going to equal what? F of g.
Wait, am I okay?
No, but you're getting into some more functions and derivatives, and wow, there is f of g's, but we're not there yet. Sorry, f of n, what? We've already got that wrote down. Are you looking at the same page as me? Times 10, right? Times 10. That's it. Oh. Anytime we're doing our formulas, what do we have to tell? What we start at. What was the first one for 5? So how would you... 14. How would you do that? F of 1, the first term. This is like A1. A1 is also same thing. 14. So what about for 6? F of 1 is 4. Okay? Now, number 7 says 49, 7, 1, 1/7, 1/49. What is that? So we're going to do geometric times 1/7. Same thing as dividing by 7, right? So f of n is what? F n plus 1 is what? Let's write this. 1/7 f n. Does it matter? Doesn't matter. Either way, you can put it before it or you can put it after it. Okay? And f of 1 is 49. All right, 8. What is that? Arithmetic. Add 10. So we're going to have f of n plus 1 is equal to f of n plus 10, where f of 1 is negative 101.